Hi everyone, today we'll talk about spinel. Spinel is a very important topic in solid state chemistry. We'll start spinel. This can be written as A B2O4. So, spinel can be divided into two categories. Like one is normal spinel, another is inverse spinel. Okay. Then what is the difference between normal and inverse spinel? AB2O4. Okay. In this compound, A present in the presence in the compound as A2 plus and B present as B3 plus. Hence we can see that B has a higher charge and A is a lower charge. Okay. And in FCC lattice, we know that there is tetrahedral voids and octahedral voids. Okay. So in normal spinel, all A atoms present in tetrahedral voids and all B atoms present in octahedral voids. That's it. Another is inverse spinel. In this case, half of the A atoms present half of the B atoms present in octahedral voids and half of the B atoms present in tetrahedral voids and all A atom present in octahedral voids. Okay, that is the main difference. Okay, so we have to remember another thing, that the occupancy. We know that in a FCC lattice there is 8 tetrahedral voids and 4 octahedral voids. Okay, so occupancy is means after the fill up means how much space is occupied by that atoms A and B. Occupancy, that is called occupancy. Occupancy is 1/8 of tetrahedral void and half of the octahedral voids. That is very important. You have to remember this thing. Okay. Now we'll start with an example. NiAlO4, that is Ni2 plus and Al3 plus. Here we'll learn that how to identify a normal spinel or a inverse spinel. So NiAl4, what is this? So here Ni is present as a Ni2 plus and Al present as a Al3 plus. Okay. So we have to calculate the CFSE, crystal field stabilization energy. Okay. We know that for P block element or S block element there is no CFSE. Hence CFSE is equal to 0 for this case. For Al3 plus, for S and P block elements there is no CFSE or crystal field stabilization energy. Okay, then I have to calculate about the Ni2 plus. Okay, Ni2 plus is Ni have all total 28 electrons, so Ni2 plus is 26, that is D8 system. Now if it is, we assume that it is in octahedral void. So we'll calculate the octahedral CFSE. So D8 system, it means like one, two, and another thing we have to talk about the O2 minus. It actually in the lattice creates the FCC structure or unit cell, and it behaves like a weak field ligand. Okay, 1 2 3 4 5 6 7 8. Okay, now CFS you have to calculate. This energy is plus 0.6 delta 0, this energy is minus 0.4 delta 0. The CFS is equal to 6 into minus 0.4 plus 2 into 0.6, 2.4 plus 1.2 minus 1.2 volt. So CFSC here it is 1 minus 1.2 delta 0. Okay, so it means that this is a negative value, so this is stable, more stable than Al3 plus in octahedral void. Means I want to say that if Na2 plus present in octahedral void, it will the stabilization energy will be minus 1.2 delta 0. But if the Al3 plus is present in octahedral voids, the stabilization is only 0. So the more stabilized energy is minus 1.2 delta 0. So the possibility of Na2 plus in octahedral voids is more. Hence in this case Na2 plus will occupy octahedral voids and L3 plus, half L3 plus will occupy tetrahedral voids. Okay, and half will occupy the octahedral voids. Okay, so this is a inverse spinel. We read about that if half of the B atoms is here is B and it is A, half of the B atom present in tetrahedral void, or half of the Al here present in tetrahedral void, and half of the total all Na2 plus is present in octahedral voids. So it is a inverse spinel. Okay. We have an exceptional case, or we can say that if both A and B are S block element, then high charged atom will occupy octahedral voids. Why it is? We have to remember this because this is very important. Because if both is S block element, then both have CFSE 0. Then we can't discriminate between A and B. But we have A 2 plus and B 3 plus. B have higher positive charge density. Okay, and A has lower positive charge density. So this needs to be stabilized more. So in octahedral void we know that there is 6 surrounding atom, means this is an octahedral void. This is octahedral, all 6 atoms, and here it is octahedral void. So the more charge density will be stabilized by more atoms, but in tetrahedral void we know only there is 4 atoms. so number of atoms is less here. So B3 plus wants to be more it needs to be more stabilized. So this is more unstabilized here, so it will try to occupy, it will try to stabilize itself, so it will occupy the octahedral void. So this is very important concept. And another is we have to check now an exceptional case. That is, what is the type of spinel is cobalt 3 CO O whole 4, this compound. Okay, this is important one to know. This is the exceptional case. So here it is cobalt 2 plus and another is cobalt 3 plus. Okay, we have to check one only. So this is, we know that all cobalt have 27 electrons. So cobalt 2 plus is 25, that is D7 system, and cobalt 3 plus is 24 electrons, that is D6 system. So if cobalt 2 plus present in octahedral void, then the CFSE will be this is D7. So CFSE you have to calculate. CFSE will be, this is plus 0.60 volt, this is minus, this will be 0.4 delta 0. Okay, so CFSE will be 4 into minus 0.4 plus 2 into 0.6. okay, so minus 1.6 plus 1.2, that is minus 0.4 delta 0. okay, here it is D6 system. D6 system means if CO3 plus present in all octahedral voids. So CFSE will be 4 into sorry, this will be 5. okay, this will be 5 because 1 2 3 4 5 6 7. okay, this will be 5, so this will be 2.0 and this will be minus 0.8 delta 0. okay, here it is 0.4 plus 2 into 0.6, so minus 1.6 plus 1.2 minus 0.4 delta 0. So this will be more negative and it is less negative. This will be, it should be more stabilized atom if it is present in octahedral void. So if CO2 plus present in octahedral void, so this should be a inverse spinel, but experimentally we got that CO3 whole 4 is a normal spinel. Okay, so why it is, we know that why it is. So we read that O2 minus is a weak field ligand. Okay, weak field ligand. But there is an exceptional case for CO3 plus. CO3 plus, if we have to know that if F minus, Cl minus, Br minus, I minus, S2 minus, SCN minus and N3 minus, only when the ligand is this 7, then these ligands will act as a strong field ligand for CO3 plus. Other than these atoms, all the ligands will act as a strong field ligand for CO3 plus. So here O2 minus will act as a strong field ligand for CO3 plus. So now we'll check the CFAC. So CO3 plus, this is D6 system. So as a strong field ligand, so all the atoms will occupy the lower energy 6 element. So the CFAC is minus 0.4 into 6, that is minus 2.4. so more stable than CO2 plus, which have a CFAC energy. But for CO2 plus, O2 minus will act as a weak field ligand. For no change in this case, only change for CO3 plus. So that is in minus 0.8. So this is more stabilized. So in CO3 plus will occupy CO3 plus, all CO3 plus will occupy octahedral voids, and all CO2 plus will occupy tetrahedral voids. So how then that, so CO3 whole 4 is a normal spinel. There is many exceptional case, so here it is, we have to know that for this case only CO3 whole 4, why it is normal spinel. Because if you do it normally, taking as a considering as CO2 O2 minus as a weak field ligand, then it will come as a, the result will be an inverse spinel, but actually this is a normal spinel. So we have to follow this rule, we have to know this case only. So by this I am ending this session. Thank you.